I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss with my student Rohan all about transformation of functions. We are going to take square root function to understand the transformations, domain and range, and the image points. In case you want to learn from me, you can always send an email on the address given. Let us enjoy the journey of success. Hi Rohan, how are you doing?
I'm good, sir. How are you?
Very good, very good. Okay, Rohan, today what do you want to learn?
Sir, today I'd like to learn about transformation of functions and how it can be seen. So, like with the different functions, like the um, uh, square root graphs, quadratic graphs, linear graphs, all kinds.
Sure, we'll look into that in detail. So, Rohan, can you tell me something about yourself and why do you want to learn this?
So, sir, I want to learn about transformation of functions because previously, in grade 10 mathematics, we started to talk about transformation of quadratic equations,
Yes.
like from the y-axis and the x-axis.
Mhm.
But I also know that there's many different kinds of graphs and there's many different kinds of transformations as well.
Correct.
That's why.
So Rohan is a grade 10 student who has just completed grade 10 and now preparing for grade 11, in which functions is a major topic. And we're going to discuss about transformations in greater details today. And I'll take up square root of function as his request is to make you understand the complete concept. Okay. So Rohan, I think that'll be nice. Okay. So let me share with you a whiteboard and then we'll see all about transformations. So we'll talk about transformations today. So let us say f of x is a function. So normally we'll consider f of x as any parent function. I want to take square root x as our function for the time being. Reason is very clear because square root x has restriction in both domain and in range, right? As you know, square
Yes,
root
sir.
x, if you sketch it, it will look like what? It will look like this, right?
Yeah, and it's only in the first quadrant as well.
Yes, it is only in the first quadrant. So we know that x is greater than equal to 0 and y is also greater than equal to 0, right? So that is the square root x function.
Yes.
So if we consider transformation of square root x, we can see how the coordinate points change, how domain and range change, and the characteristics also. Perfect. So in general,
Yes, sir.
when we say transformation of functions, they can be written as g of x is a transform function for me. I can write this as a times f of, let's say, k x minus, let's say, p plus q. So as you know, Rohan, in this particular case, a and q relates to vertical, right?
Yeah.
As far as a is concerned, it deals with vertical stretch or compression. As far as q is concerned, it is vertical translation, correct?
Yeah.
And now, if q is greater than 1, positive, let's say 0, in that case, it is up. And if q is less than 0, then it is down. Translate down, correct?
Yeah.
For a, if absolute value of a is greater than 1, then it is stretch. And if absolute value of a is less than 1, then it is compression, correct?
Compress.
1/4, right? Also, if value a is less than 0, means negative. In that case, it is reflection, right?
Reflex.
on x-axis. So A and Q, as you can see, relate to the vertical stretch compression, and Q relates to vertical translation. K and P, on the other hand, reflects to horizontal stretch compression,
Horizontal.
right? So inside parameters relate to horizontal. As far as P is concerned, if P is positive, means greater than 0, then it is right P units, and if P is less than 0, then it is moving left by those many units. Now let's look into K, which is a bit tricky. So as far as K is concerned, if absolute value of K is greater than 1, in that case, it is horizontally compressed by a factor of 1 over K, okay?
Okay.
However, by a factor of 1 over K. However, if absolute value of K is less than 1, in that case, it is stretched. By a factor of 1 over K, right? So that becomes a basic transformation, right? Very important. This is given in every book, so not a big problem, right? You know this. We'll actually see how does it affect any function, specifically the square root function in our, and how do the points, coordinate points change from the period function to the transform function, okay? So now, let's take up an example with square root function. So I'll take example 1, in which, let us say the function g of x is 2 times square root of x. 2 times square root of x means what? Can you tell me, Rohan?
2 times square root of x.
Transformation wise.
So it would mean that the graph is vertically stretched by a factor 2.
Correct.
While still starting on the point of origin.
Correct. By a factor of 2. It means that the y values will get multiplied by 2. Do you see that for the same x value? So this point here will get stretched, and every point here will get stretched by a factor of 2. And what you get is 2 square root x. You get the idea?
Yes, sir.
That is vertical stretch. Now here, if the original values are x0 and y0, in that case, can you tell me what will be the transform values on the given graph of g of x?
If x0 and y0, would it still be x0, y0, sir? 2
times y0. So every y value has got stretched by a factor of 2. You get the idea? So all these points will be 2.
Yes, sir. But only x is the same?
Yeah. So basically, if you look into the key parameters for x and y, for example, if I take x values, let's say the square root x values, then the coordinate points are, 0, 0, 1, 1, 4, 2, right?
3, 9.
4, 2, 9, 3. Square root of 9, right? But if I do 2 times square root of x, then the points will be what? So at every place, they get multiplied by 2. Do you see that?
Yeah.
Do you see that?
4, 4.
That is how the points will be.
9, 6.
So as you can see, the y value gets
doubled
by 2, right? Now, can you tell me, is there a change in domain and range?
No, sir.
No change in domain and range, right? What is the reason?
Because it's still starting at point of origin.
Yes.
So
And
there's
bring up.
nothing. So it's just going to be x of real numbers and y of real numbers.
Perfect. Good. And it is like y greater than equal to 0, x greater than equal to 0, it remains same, right? Now let me take another function, which is, let us say, h of x is equal to minus 2 square root of x. So the a value is negative, right?
Yes.
So minus 2 square root of x will mean what? The points now will be minus 2y, right?
Minus 2. Yes, sir.
So 0, 0, 1 minus 2, 4 minus 4, 9 minus 6, correct? So the graph in this case will actually be kind of like this. Do you see this?
Going downwards.
Okay.
Yes, sir.
So in this case, will the domain change?
No, sir, the domain wouldn't change,
Range will.
but range will.
So range now is that y is less than or equal to 0, right? Which is all negative.
0.
Get the idea. So if there's a flip
Yes, sir.
in the x-axis, you see domain remains safe, range changes. Now let me take example with translation. Let us say we have a function p of x, which is square root of x plus 1 minus 3. How will this graph get transformed? Can you tell me?
So p of x, which is equal to square root of x plus 1 minus 3, sir?
Yes.
So it would be shifting 3 units to the left and, wait, my bad. 3 units down and 1 unit to the left.
Correct. Horizontally translated, 1 unit left. And vertically translated, 3 units down. So that means what? It means the graph will go left 1 unit, right? And 3 units up. And so we'll have a graph which will be kind of like this. Do you see that? Well, this point will be minus 1, 3, correct?
Wait, sir, wouldn't it be negative 3? Because it's going down.
Oh, sorry. Yes. You're right. Yes. Negative. So negative. So minus 1, negative. Perfect. Do you see that? So the graph will be
Yes, sir.
congruent since there are no stretches or compressions, right? So we have a congruent graph.
Yeah.
How? Both domain and range change. Do you see that?
Yes, sir.
So
So now it would be, a domain would be x of real numbers, where x is greater than equal to negative 1. And range is y of real numbers, where y is greater than equal to negative 3.
Perfect. So the concept is clear about all this, right?
Yes, sir.
Now I'm going to add the horizontal compression and stretch. Is that okay?
Okay, sir.
So let us say m of x is another function in which we have square root of 2x minus 4. Now, can you tell me what is going to be the transformation for this particular function?
It would be horizontally translated 4 units to the right. And it would be horizontally compressed by a factor of 2.
Half.
Oh,
1 by k. So half. You see that? But you
yes,
did made a mistake for translation. You know why? Because you have to rewrite the equation taking 2 common. So we get x minus 4 divided by 2 is 2. Do you see that? So that is the horizontal translation. So it is important to know that you have to always factor the coefficient of x. You get the idea.
Yes, sir.
If I have to sketch the graph, let's say this is square root of x, And if I have to sketch the graph for square root of 2 times x minus 2, what will I do? How can I do horizontal compression by a factor of half? If this is the point, it shifts half units. Do you see that? If this is the point, it comes half units backwards. So let's say this is the x value, it will come at
Okay.
right here. So the graph will be kind of like this. Do you see that? This is square root
Yes, sir.
of 2x. You see that? Now,
Okay, sir.
we have to translate 2 units left, so it'll be like this. You see that? This graph will be shifted minus 2 left. 2 left. You get the idea?
Wait, sir, but why would it shift 2 units to the left?
Oh, sorry, right. You are right. It will go 2 units to the right. Perfect. So 2 units right, because this is 2 here. So now, can you tell me what is the domain?
The domain would be x of real numbers, where x is greater than equal to 2, sir.
Perfect. And range?
Range is going to be just y of real numbers.
Greater than equal to 0. It is not negative, right?
Yes.
So you see how the horizontal compression will be incorporated. Perfect. So I think
Yes, sir.
you have got all the things correctly noted. Perfect. You caught me twice while making mistakes. That's excellent. But now we have a test question for you. You tell me this one.
Okay, sir.
Let's say n of x is equals to minus 2 square root of 3x plus 6 minus 1. Can you tell me the transformations of this function and sketch it? Tell me first transformations.
Plus 6 minus 1.
Yes.
So that would be negative 2. We have square root 3 in brackets x plus 2 minus 1.
Very good.
So
Very good.
we already know.
Tell me now. Yes.
Oh, that's just okay. So
First thing is
first of
factor
all, we
3.
already
Yes.
know that it is vertically translated 1 unit down.
No. Okay, one
And
more thing,
that
Rohan, one more thing, one more thing. Always when you describe transformations, you have to do multiplication first, like stretches, compressions, and reflections. Is it okay?
okay, sir.
So you start with multiplications. So that really means you have to do stretch, compression, and reflection, right? Followed by
Okay, sir.
translation. You get the idea. Translation at the end.
So multiply, stretch, compression, reflection, followed by translation. Okay, sir.
Perfect. So you could describe first vertical stretch compression or horizontal stretch compression. And in this case, we do have a reflection on the x-axis. Perfect. So that will be the first set. And at the end, you will say translated 2 units left and 1 unit down. You get the idea. Follow the sequence. Otherwise,
Yes, sir.
you'll get a wrong graph. Okay.
Okay, sir.
It's very clear. If you move first 1 unit down and then you reflect, you're getting wrong answer.
Okay. So it's just reading from left to right, right, sir?
Oh, very good. So read from left to right. How do you know this formula? Reading from left to right. This is the best approach. Okay, so read from left to right and tell me each and every transformation, starting with minus. What do that minus reflect?
It tells us that if it's reflected on the
Vertical on the x-axis.
x-axis.
Then 2.
Vertically stretched by negative 2, sir.
By a factor of. Do not miss the
Factor.
word factor. Okay? Factor of 2. You don't have to say negative. Negative was a reflection, which we have already included. Do you see that? So by a
Okay.
factor of. A negative, we have already taken care of, right? Next.
It is horizontally. Is it horizontally compressed by a factor of the third, sir?
Third, 1/3. Perfect. Now,
Translated horizontally by 2 units.
left and 1 unit down. Is that clear to you?
Yes, sir.
Perfect. Now, can you tell me how will the points get transformed? Is x, y, let's say x0, y0, are original points. After transformation, what happens to the x values?
Would it become negative 2x
X
0?
value.
I mean,
1/3 of the original x value, right? Minus 2, correct?
okay.
Y values, what will happen?
It'll be 2y by negative 1.
Negative 2y, because getting reflected, right? Minus 1.
Okay.
Make a note of all this.
Okay, sir.
You have to maintain the order, stretches, compressions, and reflections, followed by translations. And then you should mention how will the key points change on the transform graph, okay? And then we'll see how do we sketch it. Is it okay?
Okay, sir. Factor of 1/3 translates 2 units left and 1 unit down. So if x0, y0 goes to 1/3 x by negative 2y and negative 2y by negative 1. So multiply, stretch, compression, reflection, followed by translation.
Perfect.
Alright, done, sir.
You remember the equation? I'll clear this page and then we'll take up sketching this graph, okay? So we're
Okay,
talking
sir.
about the function n of x, which is what? Minus 2 square root of, tell me. Minus 1, right? That was the function, correct?
Yeah.
Perfect. So I'd like you to first draw a table. So in the table, we'll write down the key points. So if I have x0, y0 value for the parent function, then we are expecting the x values to be now 1/3, and then we are going to take away 2. As far as the y values are concerned, they will get multiplied by 2 minus, and then minus 1, correct?
Okay, sir.
So your points are 0, 0, 1, 1,
1 0
4, 2, 9,
4 9 3.
Write down, calculate, write down the new points, the transform points, x and y values.
Okay, sir. So 1/3 multiplied by 0 minus 2 by negative 2 multiplied by 0 minus 1, which would be 1/3. Wait. -2 minus 1.
Sorry.
-1. 1/3 multiplied by 1 minus 2 by -2 multiplied by 1 minus 1 equals to 1/3 minus 2 by -2 minus 2, which would just be multiplied by. So that is 6/3, and 1/3 minus 5/3 by -5/3 by -3. 1/3 multiplied by 4 minus 2 is -2 multiplied by 2 minus 1, which equals to 4/3 minus 2 by -4 minus 1, which equals 6. Oh, that's 6. -2/3 by -5, and 1/3 multiplied by 9 minus 2 by -2 multiplied by 3 minus 1 equals to 3 minus 2 by -6 minus 1, which equals to 1 by -7.
Tell me your values, which you calculate. For
So
1, what
for
do you?
0, 0, I got -2 for x, -1 for y.
Mm-hmm.
For 1, 1, I got -5/3 for x and -3 for y. For 4, 2, I got -2/3 by -5. And for 9 and 3, I got 1 for x and -7 for y.
Okay, so 3 times 2, 6, 9. That's correct. Now, how will the graph look like?
So for the x, so if it's at -2, it would be -1,
Yes.
5, and 3. So if it's 5/3, it would be
Kind of like this,
1.
right?
Yes,
Kind of like this. You see that? Because it got reflected, vertically stretched, compressed, horizontally means more stress, right? And then move one.
yeah.
Right? So we have this point, which is -2, -1. So now, can you tell me domain and range?
Domain and range. So domain of x is x of real numbers where x is greater than equal to -2.
Correct. Why?
So range is y. So y of real numbers where y is, so if it's 1 unit down, it is y is less than equal to -1.
Correct. You see that? So you see this original graph is always increasing, right?
Yes, sir.
But because of this minus, this graph is decreasing. Always. You see that?
Yeah.
So there is one major change. It gets reflected and vertically stretched.
So, sir, this would be like if x for the end behavior, if x is -infinity, y is -infinity. But for the original, it's just, oh, if x goes infinity, then y is -infinity. And then for the original, it's just if x is infinity, y goes infinity, right,
Right.
sir?
Right. So end behavior changes, right? So that is an example which covers all the type of transformations. Are these absolutely clear to you?
Yes, sir.
Let me take another example with you. Another very important function is reciprocal function. Parent function f of x is equal to 1 over x. Are you aware of this function?
F of x equals 1 over x, sir?
Yes.
Okay, so this is where,
Yes.
is it that the end behaviors that if x goes infinity, y only goes positive 0? Because it, and then if x goes negative infinity, y goes negative 0?
Yes, 0 from below. So no, we don't say negative 0, 0 from below. Okay.
Okay.
From above. So we do have a horizontal asymptote, right? This is what we're trying to say. Which is y equals 0. And we also notice that we have a vertical asymptote also, right?
Yeah.
So we have a vertical asymptote, which I could show with a dotted line. So vertical asymptote is x equals to 0.
Okay, sir.
Can you tell me domain and range of this function?
Domain and range. So
Yes.
if x of real numbers,
Yes.
is it that x is
Not
not
equal.
equal to 0?
Yes. All of the values are okay, right? Same for the range, right?
Yes, so it does not equal to y.
Yeah. Is this concept clear to you?
Yes, sir.
Very good. So I'll clear the screen. You made a note of all this?
Yes, sir.
Very good. Sketch this function.
G of x is equal to 1 over x minus 3 plus 1. So this is vertically, so it translates 1 unit, no, 3 units to the right. Right. 1 unit.
You're right. 3 units to the right. That basically means that the vertical asymptote changes to x equals to 3. Do you see that from here?
3. Yes, sir.
The horizontal 1 unit up means y equals to 1. Is that clear to you?
Goes to 1.
So the
Yes,
new
sir.
function will look like this. Is that the idea?
Okay, sir. So wherever the horizontal asymptote and the vertical asymptote are, you get the two equation. I mean the two graphs, right, sir? From that equation.
Now, your exercise. Can you find x and y intercepts? Yeah. Find x and y intercepts and label the diagram.
X-intercept and y-intercept.
Yes.
So sir, I got y is equal to 0 for my thing.
So,
but I wasn't able to find out for x.
if I write x equals to 0, means y-intercept means x equals to 0, then you get y equals to 1 over minus 3 plus 1, correct? So 3 common denominator.
Yes, sir.
3 common denominator. You get minus 1 minus 3. Oh, sorry, minus 1 plus 3, right? Because this is like minus 1 over 3, right? Minus 1 plus 3.
Yeah.
Plus 2 over 3, correct? So truly speaking,
Okay.
the graph will be kind of like this. You see that?
Okay, sir.
This point will be 2 over 3. And this point will be 2. You get the idea?
Yes, sir.
So you have to find x and y intercepts. So this gives you more knowledge and more accurate graph from the given situation. Is that clear?
Yes, sir.
Good. So you now understand how do we do transformation with square root function, and also we have seen with the reciprocal function, right?
Reciprocal. Yeah.
Here is a test question. Okay, so that's your function. Can you tell me what are the transformations?
Minus 1. So one looking at so 1. So 2 over 1 plus x minus 1, sir.
Mm-hmm.
So it translates 1 unit down to 1 unit to the left.
Correct. How about this too?
It would be vertically stretched by a factor of 2.
Correct. Oh, graph it now. Points x and y will change to what? X value will be
So the horizontal asymptote would be 1 unit down. 1 unit to the left, and the vertical asymptote would be 1 unit down. So that means that x would equal to -1 and y would equal to -1.
correct. Can you sketch the graph? Find x and y intercepts now.
X and y intercepts.
Yeah, before
Okay. Will be 1 that y should equal to 2 of 1 minus 1, y equals to 1. So x as 1 and y as 1 for
Y
my
is also
intercepts.
1. Correct. Both are 1 1, and the graph will look like as shown here. You have to show the transformed asymptotes, right?
Yeah.
Right. That is how you're going to sketch. Identify x, y intercept, identify the horizontal asymptote and the vertical asymptote, write their equations. Correct?
So, sir, first, when we're doing a reciprocal function, we have to identify if it's vertically stretched, compressed, or reflected.
Yes.
The translation, like its asymptotes and also its intercepts.
Yes.
Okay.
Also, end behavior. End behavior is very important. Now, in this case, when x approaches negative infinity, tell me y approaches what?
So when x approaches infinity,
Yeah, negative infinity.
y would approach negative infinity.
Negative 1 from below. Negative 1 from below.
Okay.
Right? How about when x approaches
Oh,
positive?
negative infinity. Negative infinity. If x approaches infinity,
Yes.
y would approach negative infinity.
From above, correct.
Yeah, from above. So it'll be negative 1 from above.
Yes. Is this part clear to you?
Yes, sir.
So where did all these transformations are likely to now summarize today's learnings? Yes.
So far in today we learned about how what is transformation and its function as f of x equal to af, and then in square brackets k, and then in curved brackets x minus p, finished brackets plus q. And then what are the different functions? So for an example, understanding that a represents its vertical stretch or compression or reflection of the graph. Q showing us its translation from vertical points if it's going left or right, up or down. And then for P telling us as well its translation on the horizontal axis.
Correct.
And how if it's going left or right.
Correct.
And then along with that, we understood what's the domain and range, along with what are some steps to the following equations like a reciprocal function and a square root function as well. So yeah.
That's good. So you summarized it very beautifully. Also remember that when you describe transformations, always multiplication means stretches, compressions, and reflections should come first, and translations later, right? Plus or minus.
Yeah.
And if you actually follow the pattern describing from left to right, you will always be correct. You see that? So always describe from left
Yes.
to right, you'll be always correct. But there are more than one way, many ways to describe the transformation, since you can actually mix the order of stretches, compressions, and reflections.
Yes, sir.
So I think that's good. I would like you to watch some of my videos on transformations. Do some practice questions from your book also. That should give you good knowledge. Okay. And
Okay,
in
sir.
case there is any difficulty, you can always post your questions to me. Perfect.
Okay, sir.
Okay. I like you to go to the YouTube channel, just search my videos and transformations. Right? So you can
Yeah.
do. Let's go and try it out. So we'll just do Anil Kumar transformations. Now, transformation is a common topic which you see in grade 10, 11, and 12. So there'll be many videos on transformations. You can select some of them and then go through it. There'll be a playlist also. So if you do playlist.
Sir, I'm unable to see your screen if
Okay.
you're showing it.
Okay. So let me just share it. I was not sharing. Okay. So let me share the YouTube channel. Can you see the screen now?
It's starting to show for me, sir. It
Okay.
hasn't.
Okay.
Yes, sir. Now I can see it.
So if you just type out Anil Kumar transformations of functions, you'll see many videos where I'm discussing transformations. MCR3U is your grade 11 curriculum, right? So
Yeah.
MCR3U functions, transformations, and inverse functions, unit 1 will be good to check. So we
Let's
have
shop here. We know you love what you do.
we have many videos here, so you can select some of these videos. I'll send you the link, and actually you can actually do them on your own also, and spend some time in understanding how we do transformations. As you can see, this is the general equation from where we really begin. And in this video itself, you'll have many examples. All these examples are taken from test questions. Perfect. We did some of these, right?
Okay, sir.
You
Yeah.
might also require to sometimes write down the equation from the transform graph. That could be one thing, right? So,
Yeah.
so questions are there. And I like you to practice. And in case any difficulty is there, let me know. We can always look into that. Perfect.
Okay, sir.
Okay, then. So we'll end the class today and we'll continue from here. But meanwhile, try to do some questions from your book and from my videos. Perfect.
Okay, sir.
Okay,
Have
great.
a great day, sir.
You too. Thank you.
Bye.